Very good. That was very good. Hey everybody, I'm Levi. This is Nerdish. Brendan and Brady, are you guys going to come up, or is this just me now?
Yes. Come on up.
What do you mean, is it just
Come here, guys.
It's never just you.
It's not.
Someone's got to be behind the magic.
Look at these guys. Does it get better than these guys?
It doesn't get any better
and
than
look
these
where
guys.
I am. I'm in the middle of these
You're
guys.
in the middle. You got a bird sandwich.
Does it get to be a better place than between these two
So
guys?
can you explain to me what it's like to have a good bird's eye view of this?
Oh.
Oh,
It
all right.
looks very much like what you see.
So what are we going to be going over today?
We are doing frizz, which I will tell you what that stands for because I'm going first. Factors, roots, intercepts, zeros, and solutions. They're all kind of the same thing, and they definitely need to be understood together for you to be able to work through them very quickly.
Lucky Charms.
Of the Lucky Charms.
Guys!
That's what it sounded like you were
Dude,
doing
we're
it to the tune
talking.
of the Lucky Charms thing.
Do you mind?
Really?
Yeah, anyway.
Brent and I are having a
Interesting.
conversation.
Yeah, can you
Is
please
that from
butt out of this?
SpongeBob?
No, it is not.
Oh,
It is still from the
okay.
TV,
From
which you
TV.
never
Oh,
had.
is it from
Levi
Flubber
didn't
with
watch
Robin
He didn't
Williams?
grow up with a TV.
Got it. Okay, I'm going to start this. You wanna
How
show
old were
me
you when
this?
you asked what the big black box was that people had in their houses?
4. Me, you, Bird.
Oh, okay.
Get out of here. You can argue over number 59 with him if you'd like.
Useless.
Oh my gosh, this pink is beautiful.
Thank you.
Hey, Kevin. What?
What?
I'm not Kevin. Don't call me Kevin.
Oh. That's SpongeBob. Hi, Kevin.
Because they're super
Wow.
big fans.
He doesn't.
I
Yeah.
Crush, you
Out
know
over
us
Kevin.
very well. Get
Yes.
out of here. All right, I Crush. Okay, I apologize. Factors, roots, intercepts.
Horseshoes, clovers, and balloons.
Oh my gosh.
Rainbows.
Doesn't make any sense what you're saying.
Anyway.
Zeros.
Makes all of the sense.
And solutions.
We don't make any sense. We're dollars.
Okay. I would say that these are the 3 that you really need to remember. Factors, intercepts, and zeros. Fizz. Factors. So we're going to choose one that goes across all of them, and I will explain what I mean. If you have a factor in some equation that is x minus 2, that means that your root is 2. It means that your intercept is, let's say, x equals 2. Your 0 is 2. And your solution is 2, where x equals 2. They're all the same except for factors. Factors is when you have x minus 2. So let's demonstrate this with a function. F of x equals, I don't want to use, yes, I should use this one. So let's say it is x squared plus 3 plus 6, and let's say it's 5x here. Okay? Now, from this function, we can get all of these things pretty much. Not technically solutions. People misunderstand roots and solutions often, but this is why we factor in the first place. People, just keep seeing what iCrush said is C. iCrush, if you have any questions, please, do your thing in the Discord. Put the questions in the Discord. Ask about Brendan's personal life, things like that. So we have x squared plus 5x plus 6. We need to, and if I'm asking you to factor this, people just do it, but you need to remember that factors are pieces of a function, right? And it's, in this case, pieces of a function, but they are smaller parts that multiply together to get your bigger part. So here, I'm not going to go into how to factor. We'll do that on another night, but if somebody wants some clarification, please let me know. So to factor this, we end up with x plus 3 and x plus 2. F of x equals that. So I haven't changed anything, but I've broken this expression here down into its factored form. From here, we can figure out all of these other things. Now, Brendan is going to go more into detail about how to get from there to there. But factors, roots, intercepts, zeros, and solutions are the same concept. Brendan, do you want to take over with this particular function? And draw stuff? It's just graphing it.
Yeah, we can do that.
Okay. I don't know where I want to give this to you. Here, maybe? You can also have this pink marker, which is gorgeous.
Okay.
You know what? Yeah, that's fine. Just leave that function for you. It's not ideal for this picture, but that's totally cool. Where's Storm? I miss Storm. Storm, are you here? Say hi if you are. maybe not. Okay, so Brendan's going to go more into detail about why we factor to find these other things. That's the only reason you'll be factoring. They generally don't have you just say, okay, here's your function, give us the factored form of the function. They'll often say, here's the function, give us your x-intercept, or maybe your y-intercept. Or they'll give you something else, and you have to get back to your unfactored form or your factored form, something like that. So, Brandon, you want to go ahead?
Sure.
Do you have your own markers?
Yeah, I do. I do.
Do you want this one?
I have a pink one,
Okay.
I think, and I
Cool.
think it's pretty good.
I want to hang on to this pink one.
Okay, you can take this back, by the way. It's such a tiny, cute
It
little...
is. Yeah.
Oh, this is from Sherman.
It is.
Okay.
Yes, it is.
That makes sense. All right. So, yeah, I'll start using a different color here. Intercepts. Most of the time, well, that's mostly what I'm going to be talking about here. You guys should be familiar with intercepts, or at least one form of an intercept. So, in this first equation, I want to write it out in a form that's a little more familiar. Normally, you'll see something like this, right? Slope-Intercept Form. When you're given this type of equation, and you're asked to find the y-intercept, right? Most of you probably just think of it as that's its own thing. It's just an intercept, is b. All right, that is the y-intercept. If we have to specify this as the y-intercept, it follows that there's probably going to be an x-intercept. All right? And I will show you how to find that as well. Looking at this equation, the y-intercept, how we solve for that, right? You would plug in 0 for x. We do the same thing here. Meaning it's actually pretty simple, especially when it's in this form, to find what the y-intercept is. So it's going to be 6. There's not tons of room here, so I'm going to go ahead and count these by 2s.
Good idea, my lord.
Thanks, Brady. All right, looking at this first equation, the y-intercept we have is going to be right here. I'm going to go ahead and mess up my marker just a touch. Can you throw me a towel, by the way? I might need to erase some stuff, thanks. Ooh, all right. That is my y-intercept. So when x is 0, right here, I'm on the y-axis, that's where I'm at. Now I want to find the x-intercept, or in this case, the x-intercepts. To do this, hi, Ivanikar. Oh, it's been a while. Good to see you. The x-intercept is the same type of process. We want to now plug in 0 for y, and then solve. And this is, I'm going to write these on the other side, but this should be something you're a little more familiar with. Now the x values I'm going to get here are going to be the x-intercepts. And why that's going to be important here, we also will call those the solutions and the zeros. And these right here that Levi had said, this is the actual, these are the 2 factors. Now,
Sorry.
oh, okay. Thought you had something to say. To continue this, to solve for the intercepts, I have more than one possible answer or one solution. Okay. I am going to set each of these equal to 0 on their own. The reason I'm doing that is because they're multiplied together. If I have any 2 things multiplied together, I only need one of them to equal 0 to end up with 0. Because if I multiply anything by 0, it cancels everything out back to 0.
Yay!
Thanks, Brady. Meaning here I have x equals -2 and x, let's make that a negative, equals -3. Is this? Yeah. Okay. Meaning, if I look at this, I'm going to cross the x-axis, right? Y-intercept, I'm on the y-axis. X-intercept, I'm on the x-axis. Sorry. X-axis. I'm at -2, and I'm going to go ahead and let you know that these are going to be going by 1s because I can do that. So I am at this point, right here, and this point. Again, clean out the marker a little bit. All right. Now I know that I'm going to be able to continue out. If I go over 2, I go up 6. Pretty fancy. Over 2, up 6. And these are going to meet in the middle.
You so fancy.
Thank you. But what's important here is just finding where you cross the axes. Yeah. Are there any questions on that? On the x and y intercepts and how they're used for the zeros in the solutions and how the factors go to those? Yes, no, maybe. If not, I think we are able to move on. We can go through some examples and practice problems a little bit later after you have seen all the things we want to talk about. Okay. Doesn't seem like it. Brady.
Yes.
Are you listo? You good?
Yes.
You ready?
Yes, I am.
All right, Levi, anything else you want me to add specifically for this, or you good with that?
No, that's good.
Great. Let's go ahead.
All right.
All right, Brady, do you want to erase all this then?
Yes, I do.
Okay.
I'd like that very much.
Can you hand me another?
No?
Yeah.
A rake?
Here's your rake. Thanks.
Pink? No, I don't need that. I don't need that for it. I'll use you for it.
All right.
Hello. So we're going to do an ACT problem that has to do with factors, roots, intercepts, solutions, and zeros. And it's going to be number 59. And 59 reads, you know what, let's clean this up a little bit. Yeah, let's get that the old dry breeze.
It's
And
like
then
Febreze,
the,
it's just not as cool.
It's not as cool. It doesn't smell good. It's just dry. That's it. It dries things out.
Bird, circle number 59.
Okay, I'm going to circle number 59, Levi. That's a great idea.
Thanks, Bird.
Okay.
I know you said dope, but it sounded like you said dope like
There we go.
Homer Simpson does.
Have Brady read it, he'll understand. Yes, I will understand. In the equation x squared plus mx plus n equals 0, m and n are integers. The only possible value for x is -3. What is the value of m? So let me write this equation out. I has question on this chord, not that chord. So we have x squared plus mx plus n equals 0, and the only solution is x equals -3. This is a quadratic. Quadratics make parabolas. Sorry, that took me way longer than it should have, okay? Parabolas. And when we solve them, we're finding, as you have heard from Brendan and Levi, the x-intercepts. Those are the solutions. If there's only one solution, it means it only touches the x-axis at one place, -3. So if we draw that out, can only touch it there. What does that mean? How could a parabola only touch the x-axis at one place? Because the vertex is located there, okay? So the parabola is going to go upward from here. I know it's a positive parabola because our leading coefficient is +1, but its vertex is at -3. So what does that mean? Well, every parabola either has two solutions, one solution in this case, or 0 solutions. If it has one solution, that means that both factors are the same. Let me repeat that. If it has only one solution, both factors are the same. If you know that x equals -3, that should tell you what one of the factors is, x plus 3, because -3 is what makes that 0. But because there's only one solution, the other factor is going to be identical, meaning this is going to be x plus 3 times x plus 3 equals 0. So now we can just FOIL this out, and we're going to get this form, and we'll be able to say what m and n are equal to. So this is going to give us, I'm going to write it down here, x squared plus 6x plus 9 is equal to 0. Therefore, if we're looking for m, which is the coefficient of x, that's going to be 6, which is C. All right. M equals 6. Yes, it does, Ivanikar. Well done. Well done. Any questions on this one? That is the only one we're going to need the overlay for. So we can go ahead and just turn that off. Turn that off. Okay. Now we're going to do a couple of SAT questions. Here we go. Hello, Levi.
Hello, Bird. I got this. You go over there.
Sounds good.
Do you want to? Yeah, I guess we should do.
We do the question, or we could talk about the.
They each have 3 questions.
Oh, they do.
Yeah. So why don't you just do one last one, and then we'll hop over to theirs.
Okay. Okay. Sounds good. Here we go. Well, should we talk about even and odd zeros?
I don't think we should talk about that.
You don't think we should talk about it at all? Oh man. All right. Well, maybe if we have time later. Okay. So here's a question that was on the SAT, which we have attached below to our page. It says, our Twitch page, you know, that thing. -16m plus 8 is equal to 0. The question is, what is the sum of all of the values of m that satisfy this? Which means what's the sum of all the solutions here? Because the values of m that satisfy this are the solutions. That's what they're asking for. But they're not asking for what those solutions are. They're asking for the sum of those solutions. So this is like a two-parter. You have to first find the solutions, then you got to add them together, and that is the answer they're looking for. Okay, so to solve this quadratic, the fact that it's m does not matter. It could be the same thing with x squared minus 16x plus 8, whatever. What we can do is, if there's ever a factor you can pull out of everything from the get-go, you should definitely do that. In this case, all of these are divisible by 2. So I'm going to divide everything by 2 and get a more simple quadratic to look at. Minus 8m plus 4 is equal to 0. That's fantastic. Next thing, can we factor? That should be the next question you ask yourself. If we could factor, we'd be finding two numbers that multiply to positive 4 and add to negative 8. Take my word for it, those numbers do not exist, at least as integers. You can't do that. If you cannot factor, that leaves you with the quadratic formula, which we are going to use. So our a value is 1, our b value is negative 8, and our c value is positive 4. So with the quadratic formula, we're going to have minus b plus or minus the square root of b squared minus 4ac all over 2a, which is going to simplify 8 plus or minus the square root of 48 all over 2, which is going to simplify 8 plus or minus 4 square root of 3 all over 2. I have this weird diagonal thing that I do. I got to work on it, which is going to simplify. These are all divisible by 2, so 4 plus or minus 2 root 3. Those are our solutions. So we have two solutions because one of them is where you add and one of them is where you subtract. 4 plus 2 root 3 is one of our solutions. Our other solution is 4 minus 2 root 3. The question is, what is the sum? That has got to be the worst square root I've ever seen and produced in my life.
Oh, Bird, put that away.
I'm going to put it away. I'm going to replace it with something that is much better. Okay, so the sum means add. So if you just add these things, our radicals are going to cancel out. Positive 2 root 3, negative 2 root 3, they're gone. 4 plus 4 is 8. The sum is going to be 8. Very good. All right, let's get some questions. You guys, who's going to do the
I'm
Ivana
going
card?
to do Ivana Carr's question first.
Fantastic.
Okay.
Okay, so Ivana Carr, if you're still here, say hi so we know. We just got to erase all this garbage, or I guess you...
Garbage.
Not garbage.
Garbage day.
Mathematics.
What's the difference?
I'm kidding, I
Oh.
don't feel that way. Okay, so I take this, yes.
What am I going to use for drying them?
So, these questions, Ivana Carr, you won't see something this difficult to understand. So if you are watching and you can get to our Discord, it's easiest through Twitch, but you can get through it on the name of the video on Facebook. Ivana Carr's first picture that he submitted, or here's...
No, Discord is everywhere. On every
Okay, so yeah. On the Discord, it's Ivana Carr's first image. And this is a very confusing diagram, and I've never seen a diagram this confusing on the official ACT, so at least in the last couple of years, so I wouldn't worry about how confusing this is. I'm not sure where you went wrong, but it's possible that...
December exam.
Oh. Really?
Well, that explains why we wouldn't have seen it.
Explains why I haven't seen it. Yeah. This is super hard and a little confusing. Unfortunately, my guess is that the problem on this problem for you was with little pieces of it that really have nothing to do with math. So they say in question that we're doing number 32. It says that Carl is taking a new trip in his new car, going 350 miles on the highway. It's very important that he's on the highway. It influences all of the numbers that you do. So they tell you that he gets 4 miles per gallon. Highway. That's in the little box there, and they reference it specifically. But we need to get from 350 miles to an amount of money. Yes. We need to get to some dollars and cents thing here. And getting from here to here is sometimes confusing, but I like doing this because it shows me where I need to go, and how I need to get there is using the relationships that are given. So we have miles. We need to get from miles to money. And the connecting, what is this called again? Unit. The connecting unit is gallons. So this is a stoichiometry problem. That's what you call it in science. I don't know if you remember that from chemistry. But we need to go from miles to gallons to dollars. So what is the relationship between miles and gallons? This might have been the missed part here, because you have to use the highway miles per gallon, because it's 25 mpg combined. That's the big number on the little screen thing. But it's got to be 32 highway because the driver is only on the highway. So what we have to do here is do unit conversion. Okay, so we're going to do 350 miles times the miles per gallon, except it's going to be flipped, and I'll explain that in a second. So we're going to have, is it 32? 32 miles, 1 gallon. Okay. So we know that the driver gets 32 miles per gallon. This is 32 miles over 1 gallon. Yes, you have to flip it to cancel out. Perfect. Exactly. That is why I flipped it, because I wanted miles on the bottom, but I didn't have that here. So you just flip it, make sure you put the 32 on the bottom because it's 32 miles. Now we're here. Miles cancels with miles. Now we're at whatever this number is, and we don't have to figure it out yet, in gallons. Now we need to get from gallons to dollars. We know the price of gas is $4 per gallon. So now we're working with 4, and I'm going to do it this way, dollars per gallon. And in this case, we don't have to flip because we have gallons on top, and here we have gallons on the bottom. So now, yeah, I'll do it this way. This is normal. $4 for every 1 gallon. And now the gallons cancel with the gallons, and we're going to be left with dollars. So units can lead you to the end of these types of problems. And now we just multiply across, and I think the answer is 4375. I think that's what my calculator gave me, and it's F. So this, when you multiply, will be $43.75, which is F, I think the answer was, for 32.
All right, real quick.
Yeah.
So, Ivanikar, we will answer the rest of your questions in after we go through other questions. Robot Dancer, is there a specific question you want us to go over first? Right now we're wanting to do the math problem you had posted a few questions about. Let us know if you guys want to order those, since you kind of put a lot of them all at once. For anyone else watching, feel free to post questions. We kind of already went over the basics of roots, intercepts, solutions, zeros, and factors. So if you have any more questions on that, let us know. The math one. All right. Brady.
Sure.
You got it?
Yeah.
Great.
Okay. This
Ivanikar, do you have any questions now that I've erased all the work I've done to show this problem? It's always best to erase your work before everybody is signed off.
Yes.
After they're done with it. Yeah.
Completely, yes, because then if they want to review it, it's fun for you because then you could rewrite all of it. Right?
Yes.
Okay. Okay, this is for Robot Dancer. So the question is, they give you a couple different answers for what x could be. So x could be 1, x could be 9, x could be both, something like that. And the way that you do this is you plug these numbers in and you see if they work. Now, the thing that's confusing you, I know that you already know that 9 is fine. If you plug 9 in here, you get the square root of 36 is equal to 9 minus 3. 6 is equal to 6. That's fantastic. So clearly 9 fits the bill here. Here's what is happening. When you see a square root already written out, what they want you to do is call taking the principal square root, which is the positive square root. Okay? Square roots are implied to be positive unless they have plus or minus in front of them. So the square root of 4x, if you put 1 in there, is going to be the square root of positive 4, which is positive 2. If you yourself are the one that takes the square root, so if you have something like this, x squared is equal to 9, and you take the square root, so you are writing the square root here, that's when you can take the plus or minus of it, okay? So x in this case is going to be plus or minus 3. But when they have the square root already written out, and there's no plus or minus, that means it's implied to be positive. So this is only going to give you positive 2, which is why 1 minus 3 being negative 2 on the other side is not going to be equal to positive 2. Okay? 1 is what's called an extraneous solution. If you try to work through this algebraically and you square both sides, you're going to get a quadratic that eventually spits out 1 and 9 as solutions. But that's a solution for the quadratic you got. You then have to take those two numbers, go back to your original equation, and plug them in and see if they work. And 1 is not going to work, because it's going to give you positive 2 is equal to negative 2. Let me know if that makes sense. Okay, thank you, very good. Okay, who's next?
I got it.
Brendo.
Thank you, very good.
Yeah, got Ivana Carr's next question.
Nice.
Yeah, no, don't worry about it, Brady. I'll just clean up the mess.
It's garbage.
I know, and you left it there for me.
I did.
Thanks. Ivana Carr, we're just going to keep working through. So the next question, I guess from the December ACT. It's a similar concept to what Levi's was. It's also a little bit difficult to kind of read through all the information it's going over, all the information it's given you in the very small font image, almost a sticker. What they're asking is the cost estimates. Again, guys, for anyone watching, this is all in our Discord. The links are in all of the descriptions. We have people commenting on Twitch, YouTube, and Facebook, so if you can't see us replying to people, that's why. We do that so you can watch on whatever platform I guess you prefer. So the question is 33 in the image she posted, or they posted. The cost estimates that are given in the image are based on a certain number of miles driven per year. To the nearest 1,000 miles, what is this number? Okay. They're based on the cost estimates. Okay, that's the first thing I want to worry about. Where is the cost estimate? It says that you save so much money in 5 years, and it says that the annual fuel cost is $2,400. And both those have asterisks to talk about them being cost estimates. So we do have $3,500 and $2,400. All right, both those are estimated costs. Now, what I'm worried about is not the $3,500. And the reason I know that is because I don't know how much another car costs, how much gas the average car goes through. Right? They say that you save this much over 5 years compared to an average new vehicle. I don't know what that is, so I'm going to have an unknown here I can't solve for. What I do know, however, is that in 1 year I will spend $2,400 in gas, or on gas, with this new car. They tell us that the average miles per gallon, so average miles per gallon, are 25 for city and highway. And the cost estimates are based on city and highway. Great. And the cost of gas is going to be $4 a gallon. Throwback to like what, 5 years ago, 4 years ago? That was a real thing. Let's do MPG here as well, just so I have my units. Now what I want to do is find out how I can get from this, kind of how Levi did it, but a little bit backwards, to miles. Now, I went and kind of drew this all out because I knew what information I needed. I have $2,400, and here is my units with dollars, so let me put that there. I'm going to multiply that by something over $4. All right, I want the units to cancel. I know that that's the cost of gas. So this is $4 per gallon. So that is for 1 gallon of gas. Now my units are going to be in gallons because I can cross those off. So I know I need to have gallon on the bottom. All right.
I'm just going to start writing a sentence.
Okay. I can say that for 1 gallon, I have 25 miles. Right, that's how far I'll travel in 1 gallon of gas. And then I end up with miles and miles. So I'm set. I multiply this all together, and you end up with 15,000. And I think that's answer B. Ivana Carr, does that make sense? Also, are you still here? I assume you were. But if not, can still be helpful to anyone else. Yes, thank you, great. All right. We will continue. You have, okay.
I have a long sentence to write. Absent.
Which one of these is your wet rag?
The left. You're on the wrong side. There you go.
Thanks.
Which in turn.
All right. I think I have some people from high school watching right now, from my high school. And I know some people I went to high school with are now teachers. Is it like faux pas to tag them?
Super faux pas.
Is it not kosher?
Totally faux pas.
It is totally kosher, though.
I hate both of you.
Did we help your decision there?
The kosher part helped.
Okay.
There's a Venn diagram of faux pas and kosher.
It's just a circle.
It was a false pas.
Only
Yeah, is that
kosher.
spray? Like,
Yeah, it's pretty strong. I don't know why. Maybe we're at the bottom of the bottle.
I think we
It's
are.
a little stinky.
mm.
You could cut that with some water.
Here you go. Here's your.
Thanks, sir.
Yep.
Okay. Robot Dancer, are you here? Also, keep asking questions. These questions are great. Now, we understand that you're paying attention to us explaining questions, so that's good too. So we have is. Hello.
Oh, my cousin's watching. Hello, cousin.
Hello, Brennan's cousin. Go away.
Well, no, that's not nice.
That's super negative. Stay here. Is being. I also am not entirely convinced you have
Family members?
family members. Yeah.
Okay.
Your words.
That's supposed to bother me?
No, I've never met any of them.
What?
Okay,
I only did it once.
now back to business. Robot Dancer. This question is very misleading, but first step, I'm sure you know what this question is about. It's about verbs, right? You're trying to choose the correct verb to go with yes, and you chose are. So is that the right answer? You know the answer to that. It's no. Hey, can you shut that off?
Brendan wants it on.
Okay. Okay, you can just close the door, and then we'll deal with it later. Brady.
No.
Anyway, don't say no. That doesn't help.
No. Closing the door would do nothing.
No,
Okay,
we'll tell you later.
Now, here, we know that we're choosing between is, are, is being, and have been. So these are a little messy, but we need to figure out. Let's see the difference between is and are. That's the easiest difference to figure out. This is tense stuff. These are the same tense. They're both present tense. We may or may not need that, but we need to figure out what subject goes with this verb. So that's what we're doing first. Let's read through this. Like any other health problems, these things increase employee absenteeism, which in turn blank costly for employers. So, what thing or things is or are costly for employers? Is it, so I'm just going to underline the nouns here. We have health problems, so that's one noun. We have, I guess, things. We have employee absenteeism. We have those three nouns in this sentence. Which one is doing this verb? I think it's employee absenteeism because it says which in turn. So we're not saying that health problems, I guess health problems wouldn't make sense because it's like any other health problem. So we have things. And we're not saying that things increase employee absenteeism and those things also are costly for employers. Oh, I thought health problems was a subject because I think employee absenteeism. Yes, correct. Employee absenteeism is the subject. It's technically not the subject of the sentence. That's actually things, but the noun that is responsible for this verb is employee absenteeism, which is singular, so it's is. D would be wrong for the same reason as B, and then is being doesn't make sense. You're not is being costly, because that's horrifying. Okay? And it seems like you got this one, so good. I do recommend, how do I find the noun connected to the verb? It's context, mainly. So, what is costly for employers? Employee absenteeism is costly for employers. Health problems are costly for employers, but that's why it says which in turn. So there's not a perfect way to know. There are a bunch of nouns in the sentence, and it's not like the first one or the last one is going to be the one that does your verb. But what you can use is context. So you have to think about it. It does actually take a little bit of work aside from here, just the strict rules of grammar.
Okay, Ivanikar, this is your last car question, which is number 34. Based on the annual fuel cost estimate for this car and the estimate for how much Carl will save in fuel costs over the next 5 years, what would be the expected annual fuel cost of an average new vehicle? So a couple things that are on the chart is that the vehicle that he's thinking about purchasing, the annual fuel cost is $2,400. So this is annual fuel cost. Here we go. Very good. The other thing that this this board tells us is that by getting this car, he's going to save $3,500
By switching to Geico?
by switching to Geico, which is one of our sponsors, over the next 5 years. Over the next 5 years, compared to an average new vehicle, which is what they're asking about. What would the fuel cost be for an average new vehicle? All right. So this is only in terms of 1 year, and this is in terms of how much he's going to save over 5 years. So we have to connect these two. We have to figure out how much he'd be paying over 5 years with this car he's thinking about buying. If this is an annual fuel cost, you just multiply it by 5 to get how much he's going to spend over 5 years. So let's go ahead and do that. 2,400 times 5, it's going to be 120,000. No, 12,000. Yes. Well, that's the right number of zeros, but the comma's in the wrong place. Here we go, $12,000. Fantastic, $12,000. Now we go over here. If by spending $12,000, he saved $3,500, in order to find what the price that he would be hypothetically paying if he got a crappy car would be, we have to add this back. This is money he didn't have to pay. He only had to pay $12,000. We have to add this back now. So we're going to take 12,000. We're going to add 3,500 to it. We're going to get 0, 0, 5, 5, 1. $15,500 would be how much an average new vehicle, hence, like in quotations, the crappy car, would cost you over the course of 5 years. The question, though, is not about how much the 5-year cost would be for an average new car. It is the expected annual fuel cost of an average new car. So this is for 5 years. We have to find what just the annual cost is, which means we have to redivide this thing by 5. So 15,000 divided by 5. This is actually going to be not too bad, because 15,000 divided by 5 would give you 3,000, and then 500 divided by 5 would give you 100. So $3,100 would be the expected annual fuel cost of an average new vehicle. Any questions about that? Otherwise, I think it's going to be another robot dancer question. Ivanikar, any parts of that you want me to talk about? I think you got it. Good. Good, good, good. Let me clean up this garbage so Brendan doesn't have to. So Brendan doesn't get to.
It's neat.
All right. Okay. Having a good time.
Feels we're having a good time.
Having good. I'm a superstar blasting into space. Then I'm having a good time. That is what I am. I'm a rocket ship. Pretty sure those are the lyrics.
Sentence combos. Okay, robot dancer. This is number 7 that you asked about. Hey.
Mine was too wet. Keep going.
Okay. Sentence combinations. In the grammar section, the most important stuff is going to be under the heading of clarity. No matter what the question is, things need to be clear. That's number 1. Now, that also applies to sentence combination questions. And it applies in a way that may not necessarily be super readily obvious. So, of course, if there is a grammatical error or a punctuation error, you will pick those out very quickly with these sentence combo questions. And the one that you got wrong, that you asked about, number 7, it doesn't have any of those. So it's not an issue. So we have punctuation, that's pretty easy. We have grammar, a little bit easy, not quite as easy. But those aren't an issue in this question, and none of the answer choices can be gotten rid of for that. Now, we also have context. Now, context has a bunch of things under it. For these sentence combo questions, transitions, especially with this one, and I'm not going to write out the entire question, but transitions is a big deal. This is why the answer that you put, which I think was C, is wrong. Because the previous paragraph, which was on a different page, which is why it's easy to miss. This previous paragraph, and then you have your sentence here, and then you continue on with this sentence's paragraph. This paragraph was about morale. Right at the end, it says that some company is somewhere boosted people's morale with natural light.
Is Al a nice guy? Do we want more of him?
More ale.
Oh, that's not cool.
Yeah, going to a tavern. Rolling dice. Anyway, morale? Oh, now it sounds weird to me, Brendan.
You're welcome. Morale.
Morale. That's what it talks about. And then in this one, it talks about cost. So, A, B, C, and D for this sentence combo question had all the same information. None of it was lost. But C has it in the wrong order. Just the order of this sentence. If this is supposed to serve as a good transition between these two sentences, then it should start with morale, and then it should move into cost. So that's what it does. Now B and D do that as well, do that correctly, as does A, but B and D are all a little bit out of order, which is where concision comes into play. And I think this has an overlap with clarity in this case. Concision is basically not redundant. Generally, that's the main thing. I looked at the shortest one and it sounded straight to the point. Okay, I don't particularly like that strategy. That is, a last resort strategy, which is fine. Maybe you got to that point when you were doing this question. But these things all need to come first. Shortest being best is not necessarily true, and it's a pretty simple thing to think about rather than just do that, which is you want to be short and concise, but you also want to be clear. That is more important than being concise. That's why clarity is number one. And it is unclear to have a transition that you were talking morale, morale, morale. Despite the high cost, morale is great, and then we talk about high cost. It's a little misleading for the reader. Now, it's hard to think of that, just come up with it yourself, but I'm giving it to you. So, shorter being better can be true. You definitely say what you need to say in as few words as possible, but it needs to be clear. So in this case, I think the transition thing is an issue. Don't go with shortest is best, because if we say, I like Bob and Ben, Brendan
Yes.
likes
Uh-oh.
him too. Well, these are short names, but for this is a little bit shorter than if we were to say here Ben, right? It's a little more concise to say him, but it doesn't make sense because we don't know if we're referring to Bob or Ben when we say Brendan likes him too. So what you need to do is be clear. It's clear to say Ben because then we know about whom you're talking. So in this case, Brendan likes Ben too, not Brendan likes him too, because that's unclear. Okay? Questions on this robot dancer. These sentence combo ones are hard. They're wishy-washy for sure. But go through this checklist. It needs to be clear. Punctuation and grammar are generally pretty easy to figure out. Don't start with shorter is better. That should be your ending thing if you have 2 seconds left. Any questions?
All right.
So they are always in order.
Oh, no.
Yes. Because now it's in order when you are proving 3 answers wrong. That's what I'm saying. So it doesn't mean that if you look at answer A and you say, "Oh, the punctuation's correct," that means it's the right answer. Oh, sorry. So they are always in order. Yes. It's in the way that the sentence was structured, because the sentence it's the topic sentence of a paragraph. So it needs to lead out of the previous paragraph and into the following paragraph. That's why in this case it needed to be in order. Now context matters. So I'm sure there are situations where you have a sentence that pulls things out of order, but it would have to be for a particular reason. I would say, as a rule of thumb, yeah, you want to stay in the order that's given to you on either side.
Good.
Yes. It's similar to questions like the sentence ordering questions, where they say, where should you put sentence 3 in this paragraph? Should it stay where it is, or should it go after sentence 7, or whatever it might be? Same idea there. The contextual part of it needs to be in order. So contextually, we had morale leading, morale. Oh my gosh, you really messed that up, dude.
No. You were pronouncing it morale, which is why I made a joke of like, what about Lesavow? Is he a good guy? Or
That's how. Okay.
Morale?
But now I can't even say it.
Morale.
Okay.
Not morale. Morale.
Morale.
At least that's how I say it, and I'm from the Midwest, but I also say things differently, apparently. Like, I get car insurance. Apparently, how are you supposed to say it?
You said it kind of fine there. Because you said car in front of it. Anyway.
Insurance.
Robot dancer, generally, yes, you want to keep the order that's given to you. And, yeah, I don't see why you would put things out of order in a single sentence. So, yeah, should be in order all the time. Should I erase these now?
I'm going to do Robot Dancer's last question here.
Okay.
Ivanikar and Robot Dancer definitely gave you guys some trouble for posting 3 or 4 in a row in a pretty friendly way, I hope. Feel free to continue to post questions now that we're getting through them. Now on to Robot Dancer's last question.
Well, I don't know. Don't feel free to do that. Do that. Don't feel like you have a choice, is what I'm saying.
Oh, got it.
You don't have a choice. Did Bert go tutor a child?
Yes.
Cool.
All right. This question, for those of you who are following along in the Discord, it's going to be, I believe, the 3rd picture they posted. And it starts with thus. All right. That is what we're underlining here. The word thus. All the options are no change. So thus, we have nevertheless. Nevertheless. Just such a weird word. Alternatively and finally. And what did I say? Finally. They all have commas. For these questions, we're talking about transitions again. Transition words. It is super, super important to read the context. Or read it in context. All right? I don't know which one of these to use until I have read the sentence before it. Because I am transitioning from one sentence to another. One idea to another. And I need to know if they are agreeing with one another, they're disagreeing, they're completely different, or in terms of finally, whether this is the end of it, right? This is the last thing I have, and this is my final one. I'm letting you know that finally, here we go. So if I'm going to start, I can, just by glancing, I can tell you that this isn't going to be finally. Because this is the second sentence in a paragraph. So I know it's not going to be finally. This should not be the last thing someone says in a paragraph. Or this shouldn't be the last thing someone says in a paragraph, right, if it's the second sentence in a paragraph. Alternatively, nevertheless, thus, okay, I'm going to leave all those there. They still, for now, seem fine. I'm going to read this. It says, among the possibilities to reconfigure a building's lighting is the installation of full-pane windows to allow the greatest degree of sunlight to reach the office interiors. All right, so we're talking about installing windows to light an office, okay? And that was one of the possibilities. Thus, nevertheless, or alternatively, businesses can install light tubes. And then they explain that these are pipes placed in workplace roofs to capture and funnel sunlight down. Okay, don't really care about that. When I read this, I see 2 different options, right? You can do full pane windows. You can do light tubes. And if I keep reading, I think there's a 3rd one, but it doesn't really matter right now. Glass walls. We need to think about what the definition of each of these words are. If you know these words, and you have read those 2 sentences, this should not be a difficult problem at all, because you know exactly what they're trying to say. You know how they're trying to transition from one to the other. Among the possibilities is a full pane window. Does that mean thus businesses can install light tubes? Does it follow that this is going to be true? No. That's not what I want there. It's not from here to there. This happens, thus this happens. It's not a cause and effect relationship. Nevertheless, so you can do this. Nevertheless, businesses can do this. Not really. It might sound good, but it really doesn't fit to say nevertheless. But I guess we could keep that as a maybe if we weren't too sure. the last one being alternatively. So they say you can install full pane windows. Alternatively, businesses can install light tubes. That sounds really good. That's exactly what I want. You're giving an option, you're giving another option, and now to transition them, I'm letting you know that I'm going to compare these, or at least I'm letting you know that there is a different choice. So you can do this, or alternatively, you can do that. Great. Hey, thanks for the follow, Lotto Dotto. I'm assuming is how you pronounce that. Great. If there are any more questions, guys, feel free to post them in the chat. Post them in the Discord. The Discord is down below in everything. I guess Facebook, it's up above. Whatever. We do this for free 5 nights a week, Sunday to Thursday,
And
8 to 9:30 p.m.
Friday and Saturday you have to pay.
Yeah, no. We just don't do it on the weekends. Because we're humans too, and we want our weekends.
Lotto Dotto.
Right, Lotto Dotto. I thought I said that right. It's just kind of weird.
But in a good way.
Yeah. Rather be weird than normal. Especially when
Yes.
you're thinking of names. Yeah, we have
Within
some
reason.
practice tests down below or up above at Facebook. We have links to our Twitter, our Facebook, Twitch, YouTube, for all of those, for all of you who are not on one of those. Feel free to check those out. Give us a subscribe, a like, a follow, a subscribe. I think that's about it. But yeah, we answer questions about the tests in general. That can be anything. Last night we actually answered quite a lot of questions to a couple individuals about like college and life choices. I don't know. We've done some of those, so feel free to ask us.
So many life choices.
Ingoing and outgoing. What is that? Great. Thanks for the question. So we have some ingoing and outgoing problems. So those are math practice sheets. That is only on Twitch right now because there's only so much we can put in the descriptions of the others. But yeah, thanks for pointing that out. I might try to see if I can finagle those into the other descriptions. For
Yeah, to click on it, just click on the thing that says ingoing, outgoing, and there are
maybe 20.
some. Yeah, there are 2 worksheets on each of the topics that's there. It's not an exhaustive list of math topics, and it's only math. Ingoing is easier than outgoing, and there's no answer key because, and that is a design so you come back to us and ask us questions.
Yep.
And we're allowed to do that because we made those.
And because this is free. What do you want from us? Ideally, answers to questions you're going to be asking, but you know. All right, you got this one? Oh, you mean is this? I thought we already went over all these.
Yes.
Okay, great.
But
Levi
I'm
wants
doing
to make a
something
point.
else. Yes.
Is the ingoing or outgoing SAT or ACT? It's both. So those math problems can be on both. One in particular, the ACT has a couple of different math topics that the SAT doesn't. I don't think there's really much that goes the other way.
Yeah. Matrices is the only topic that's in that folder that's only on the ACT.
Yeah, everything else should be both. For English and grammar and the math section, it's almost completely the same. Pretty much the same for the English and almost the same for the math. Absenteeism. That and like skiing, it's just weird when you have 2 I's next to each other in a word. Great. If there are any questions, let us know. If you guys want to go ahead and share this with your friends, go ahead and do that.
Okay.
I'm sure you're not the only one who needs practice with the SAT and ACT.
Robot Dancer and Ivanakar, if you're still here, and anybody else who happens to be here, please tell me what the uses of all of these commas are. So we have a comma here, and we have a comma. Oh, forgot a comma.
Oh.
Should have a comma there.
Oh, man.
And then we have a comma here, and we have a comma here. What are the uses of these commas? Should I practice English, ACT English, for better timing on SAT? Sure. They are the most similar of the sections that cross over the tests, so it can certainly help you. Yes, you should still practice SAT questions and tests, but if you're possibly running out of those, then yes, definitely practice ACT stuff. It will help you a lot. There are some question types on the SAT that don't pop up as much on the ACT, but it'll certainly help. More so than any crossover section elsewhere in the test. Okay, does anybody know where these commas come from, what type they are. Since SAT has free questions on Khan Academy, is there a website with ACT questions? Not in the same way that Khan Academy does it in such a robust way that allows you to work up your levels and all that. No, I don't think.
Nah.
There's UWorld, but
it's not free unless you have a specific code for it.
It's not free necessarily, and the math is generally what they do better.
And I don't like how they phrase a lot of their questions.
Yeah, all that. Comma which is for absenteeism. Yes, so which describes absenteeism. What type of commas are they? And do you know the 4 uses of commas? Because I'm happy to hop into that. I think next week we're planning to do that, but I don't care to do it now. If you're not sure of all 4 of the uses of commas on the SAT and ACT, they do some other weird stuff, but the 4 uses that will get you through the test. Comma phrase. I don't know what that is. Maybe that means something that is correct. Comma phrase. Like, do you mean a non-essential? Because that is correct if it means non-essential. And that's what I want to talk about. Isn't that when there is... Yes, non-essential. Non-essential. It's also called appositives. That's the technical term for it. But I like saying non-essential because it sounds like what it means, and then you don't have to think about other stuff. Okay. So, in this case, yes, this comma is for a non-essential. There are ways to do non-essentials, several ways. So, this comma is a standalone comma. And the non-essential is this whole thing here. Because your subject and verb are the main kernel of the sentence. They make up the independent clause. And the main part of the sentence is these things can increase absenteeism. Things can. That is actually technically the independent clause here. Things can. These things can increase absenteeism. And then you have this whole thing, which in turn is costly. This whole thing is a non-essential. My teacher calls non-essentials comma phrases. That's interesting. I wouldn't do that, personally, because you can use other things to separate non-essentials from the rest of the sentence. You can use commas, you can use parentheses, and you can use dashes. Kind of looks like a weird thing there, but yeah. Commas, parentheses, dashes, and non-essentials, or comma phrases. Sure. So in this case, we have that one. But then within that one, we have another one, which is in turn. Because we could just say, these things can increase absenteeism, which is costly. But we want to say in turn, so we put commas on either side. The reason why this is a single comma for an entire non-essential, whereas this has 2, is because the non-essential here goes until the end of the sentence, and you don't need another comma because you just have a period. The sentence ends. The commas or the parentheses or the dashes, they are used to offset the non-essential from everything else. But if there's a period, there's nothing, from which to offset it, so you need to just have it on one side. Now, this is also a non-essential. It's just at the beginning. So we have a comma here to separate it from this part of the sentence, which is the main part. So just because we have 2 commas here and here doesn't mean that this is non-essential. And you need to use context to know that. If you don't know anything about subjects and verbs and what we're trying to say, then you could think this is the independent clause and then this is all non-essential stuff. That's not the case. The essential part is in the middle, non-essential here, which is like other elements, because this is talking about things. It's actually saying like other elements, these things. So this describes things, and then this describes absenteeism. And that's how non-essentials work. They can go before or after the idea that they describe. Commas to offset, parentheses to offset, dashes to offset. You don't need 2 commas if you have a period on one side or the beginning or the end of the sentence. Same thing with dashes. You do always need parentheses, but I don't think I've seen a question that only uses 1 parenthesis, and that's why it's wrong, because it doesn't have the closing one or something like that. I've never seen that. Any questions on all of this garbage here? It's not garbage. It's fun. Commas are fun. If you can do commas, that means you have a very, very solid grip on grammar and punctuation, because it's by far the hardest punctuation on the test. So if you can do commas, you should be able to do dashes, parentheses, semicolons, colons, which sound harder, but commas are certainly the hardest because there are so many uses. Questions on that? Is your testing website up? Ah,
Not quite. We're getting there.
very close. We will certainly let you know when. You want to give them a timeline? Or
No.
No.
There's one more bug I have to fix, and I'm not sure what the issue is.
There about
Currently.
yeah, there is one bug. Just one pesky little bug.
It works not on Amazon, and then when I'm on Amazon, it doesn't. So we'll see.
Good. Sounds ideal.
Yeah.
Can we do long division for Algebra 2? Oh yeah, long division definitely works. What's up? Oh,
Hey, Svea.
hi Svea. Long division. Yes, we can. Okay. Not sure how long we're talking, but let's say we have x minus 3. Let me know if you want something more complicated than this. Okay, let me make this up and make it work well. You know what? It doesn't really matter, because I want it to be long, and I'm not going to be able to think of this in my head.
Gross. Does she mean polynomial long division? That's what you're doing.
Oh, do you need... Sorry, yeah, I should clarify. Do you mean polynomial long division, or do you just mean normal long division where it's just constants?
Large numbers.
Wait, can we do x squared? You want x squared here, or something more basic up here? Do you want this? Blink twice if you want this to be x squared.
1 or 2. 1 is on the bottom. So yes, polynomial.
Yes, polynomial. I'm going to change this to x squared. Stop me if that's bad.
Cold bugs.
Yes, like x squared minus 3. Okay.
You're
Shoot.
good there.
I think we're good. I think we're good. Okay.
No, don't change that.
If you would like to give me a problem, please do that. That would make
It
me
makes it a
clear.
little simpler.
Yes. Otherwise, I will keep bumbling.
I just want to be up here to bother you now.
X. Yeah, please.
All right, x to the 5th. Ooh, hold on. Yeah, okay.
Yeah,
Wait,
we're gonna
wait.
have a problem,
Leave it,
which
leave
is good.
Yeah, I'm gonna put it in here so that you can write the stuff on top there.
Yes. Is that what I was doing the whole time?
Yeah.
Oh, jeez.
Yeah, x to the 5th minus 4x to the 3rd. I'm gonna skip it. X to the 3rd plus 5x squared plus x minus 3. We'll see if that works.
Yes.
It might be pretty
Feel
nasty.
free to give us a problem too. That's fine. But if you're happy with this, we'll just do this. Now, we have an issue here.
Oh no.
We don't, if we want it to be nice, where we have x squared plus, you want an x term, an x, or x squared term, then an x term, and then a constant term, whatever it might be. We don't have that here, and we don't have that here.
Now,
we go,
that
go ahead.
works here though. You're welcome. I didn't think about it all the way, but that works with the first step.
It does work with the first step.
I don't
but-
expect it to work past that.
Yeah.
Yeah, no,
Yeah, it won't.
no, it's okay.
Unfortunately. Because we're skipping that x term in the middle here, and we're skipping the x to the 4th term in the middle here, I'm going to rewrite this so that it's much clearer and spread out. So it'll take an extra minute, but that's okay. So we're going to say x squared plus 0x minus 3. So nothing has changed. We just added a 0x in there. And then we have x to the 5th plus 0x to the 4th, because we don't have it, minus 4x cubed plus 5x squared minus 3. Nope, I forgot an x. Plus x. It's okay, Brendan.
I don't know.
Dang
what
it, it's
is.
not okay.
Nice.
Plus x minus 3. Okay, now we're actually ready to go. First step. you divide. How many times, and you only have, so when you're dividing with polynomials here, you don't actually care about any of these things here. You only care about this one, and you only care about this one. So whatever's here, you're always only going to care about the x squared for now. And then as you go through here, whatever you're starting with, this first term is what you care about. So the question is, how many times does x squared go into x to the fifth? Which is just a fraction. It's x to the fifth divided by x squared, which with your power rules is going to be x cubed. If that's an issue, this will be an issue, so we can take a sidestep and do the
Exponent rules?
exponent rules, power stuff. Yeah. If you want to do that, let us know. If this is fine for you, then we'll
You'll
move on.
continue, and if so, I'll go over that if we need.
Yeah, cool. Yeah. So now, this is our quotient. We have x cubed. Are you with us so far, Svea? Please say hello, or say yes. Now, just like in normal long division without polynomials, you take this number and you multiply it by the entire thing here. And I'm going to preemptively put this in parentheses and subtract it. Okay? I don't like flipping negatives or anything like that. I'm going to put parentheses here, and we're going to subtract the whole thing. But first, x cubed times this whole thing. So we distribute it to each term in this expression. So x cubed times x squared is going to be x to the fifth, which it should be because when we subtract them, it should go away. That's the whole point. Now x cubed times x squared, x to the fifth. X cubed times 0x is 0, and that's actually nice. So 0x, and it would be technically 0x to the fourth. It doesn't really matter. We're going to leave it with the x to the fourth. Then x cubed times negative 3x, which will be minus 3x cubed.
Yep.
Going to rewrite this. Okay. Draw a line, and now we subtract. Careful of distributing negatives. So x to the fifth minus x to the fifth is 0x to the fifth. So that's gone. 0 is here as well, so we have 0x to the fourth. So we really just don't care about either of these. And then we have negative 4x cubed minus a negative 3x cubed, which is going to be negative 4 plus 3, so it's negative 1. So we have minus x cubed. Happy? Maybe. I don't know.
I'm going to use a different color here for the bringing it down.
Okay.
Keep going.
And now, Brendan's bringing down everything else. Not because that's some crazy thing. It's just what's left over after we've subtracted. Now we have this whole thing. Again, we only care about that, and we only care about the leading term here. So how many times does x squared go into negative x cubed? Just...
For each step or not?
Nah.
Okay.
So here we have negative x cubed divided by x squared. This will end up being negative x. So, negative x. Are you getting kind of lost in the swamp of things here, Svea, or anybody else? Or does this make sense so far? We divide, take the first terms, put it up there, then multiply everything, subtract, bring down. So it's divide. The way I remembered it when I was in high school was divide, multiply, subtract. Bring stuff down. Divide it in, multiply, subtract, bring everything down. So now we have this negative x here, multiply it through. So we have negative x times x squared. And I'm going to do the same thing. So we're subtracting this entire thing here. Negative x times x squared is negative x cubed, which should happen. And then we have a 0 again, so we'll just do plus 0x squared. It doesn't really matter if you write the x squared there or not. I just like it because it's in line with the x squared term. And then we have negative x times negative 3x, which is plus 3x. Then we subtract this from what's above it. Negative x cubed minus a negative x cubed is 0x. So we have 0x cubed. And then we have 5x squared minus 0x squared. So we're just left with 5x squared. And then we have x minus 3x. So we have minus 2x. and then I'll bring down the negative 3 to there. Happy? Maybe. I don't know. Let me know if you're happy. And this doesn't matter anymore because we have a 0. Last step. There's just one more step. One more normal step. So now we have 5x squared and this x squared again. That's all we care about. So how many times does x squared go into 5x squared? Just do that real quick. These cancel, so we have 5. We just have a constant term, which lets us know that we're probably done after this step. And it's all positive, so we just have plus 5. So 5 times x squared. Let's do this thing again. 5 times x squared is 5x squared. Then we're going to get that 0x again. And then we have 5 times negative 3, which is negative 15. Then we subtract, and we get those two to cancel out. We get negative 2x. Negative 3 plus 15, which is plus 12. Okay, now we're going to try to do it again, and we're going to run into a problem. We have negative 2x divided by x squared. This doesn't simplify nicely. All these other ones left us with x or left us with 5 at the smallest. Here, we're left with, when we cancel things out, we get negative 2 divided by x, which is technically negative 2x to the negative first power, which doesn't really work. You don't want negative powers and things like that here. So once your divisor is bigger than your radicand, it's not the radicand.
What?
Never mind, it doesn't matter.
Numerator, denominator?
No, it's fine. So this negative 2x is bigger, or is smaller than the x squared. Why did you do a negative outside the negative parentheses? Because you're supposed to subtract. So you're seeing how many times this thing goes into this thing. And we're doing that biggest term first. So you're always going to be subtracting what you just found. So, if that didn't make sense, the first step, we have x squared going into x to the 5th, x cubed times. So you do x cubed times all of this, and you take it away from what you started with to see what's left over. That's why every single time. And we keep doing that until we get to something that's too small to divide. Now we're left with this. That's just our remainder. So we're going to get x cubed minus x plus 5 with the remainder. You can write this a couple different ways. You could say plus negative 2x plus 12 divided by x squared minus 3, because that was what you were dividing by at the beginning. So it's just this is the remainder. You could just write it as x cubed minus x plus 5 with r negative 2x plus 12, however you want to write it. Do you have any questions on this as a whole? So you said you get it. I think I was talking about just the minus thing. Any other questions on this?
I'll take the next one.
Cool. Is there a question on Discord or no?
She has one right there.
Oh, she has hers. Okay.
I'll take it over there.
Sure. Yeah, I can erase this quick-ishly.
Also, if there's anyone else who has any other questions, feel free to ask them. Doesn't have to be related to this at all. If you also don't understand how to do this well, or you want some more practice,
Follow along, ask questions if we say or start anything that does not make sense.
Great. And if you have no interest in this, then ask a different question.
Yeah. All right. Thanks. So we have 2x to the 5th. Where are we at? Plus 4x to the 4th. I hope this one gets a little bit clean. Maybe not. This is not ever supposed to be perfectly clean. 4x to the 3rd minus x minus 3. Divide by x squared minus 2. Now, we're going to be doing the same process. So, like Levi had said, I'm worried about this value and now this value. Meaning, to get from here to here, I'm going to multiply by 2, because I need that coefficient, and x to the 3rd. I'm going to go ahead. I like how Levi does it. I do it very similarly. I don't like trying to plug the negatives in. So I have 2x cubed times x squared, 2x to the fifth, minus 4x cubed. All right? Now, you can leave it like this. I'm not going to necessarily do it the same way Levi did. I like just going right under wherever it is and spacing it out that way. If it helps, you can definitely put plus 0x to the fourth, but that'll probably be the last time I do that in this example. I just line it up by whatever the power of x is. Go ahead and solve this. Simplify it. This is 0. I have 4x to the fourth. I have 4x cubed minus a negative, so plus 4x cubed, so that's 0. And then I have minus x minus 3. Oh, that's kind of nice. Did you see that one, Levi?
Nope.
They simplified at the same time. We got rid of 2.
That's fine.
Mm-hmm. Now, I'm going to go ahead and use a different color. Keep our steps different. Now I'm focused on these two. The answer is 42. Yes, the answer to everything, the answer to the universe is 42. Thanks, Siddharth.
Sid.
But what is the question, Siddharth? Because that's the important part. Also, good to see you.
Hi, Sid.
All right, I'm trying to get x squared to 4x cubed, so that's going to be a positive 4x cubed. That's going to be 4x squared. Go ahead and solve that. Plug it all in. I'm going to have 4x to the fourth. Great, that's what I wanted. Minus 8x squared. Let's go ahead. I'm going to end up with these canceling out. I'm going to get a plus
Can you answer a question?
8x squared. Why did I subtract what?
The only thing you're subtracting is.
This or this? Hey, thanks, Sid. It's like, why did I subtract that? So, a little more specific on that. Think of it, this is the exact same thing as regular division. Let's do this a little different. Make this like 3 and something that's not 3. 3 divided, what is this? Let's say 17 divided by 3. Can you scroll down, Levi? For some reason, it's not wanting to do that. I would say 3 goes into 17 is going to be 6 5 times. That's going to be 15. I subtract them, and I'm left with 2. Right? And then I have a remainder of 2. It's the same process here. Why did I subtract this? Because it's a negative here. So x squared minus 2 multiplied by 2x cubed. So a positive x squared times 2x cubed is going to be 2x to the fifth. 2x cubed times a negative 2 is going to be negative 4x cubed. And then, like we would do in division, or long division, I'm going to subtract that whole quantity. So a negative 4x cubed minus a negative 4x cubed.
It should be 8. Oh, no, you're right. Never mind. I don't know why she said.
Right? Unless I made a simple
No,
arithmetic here. I don't think so. So this is negative 4x cubed minus a negative 4x cubed. Those are going to change into positive, and those cancel out. Does that make sense? If not, let me know. I'm going to continue with this step. All right. You get it. Great. So we ended up with 4x to the fourth minus x minus 3. We said to get from x squared to 4x to the fourth, I need to multiply by 4x squared. I did that. I'm left with 4x to the fourth minus 8x squared. Now when I subtract that, the negative x and negative 3 get pulled down. I didn't have just an x term, so I couldn't do anything with that. And here's what I get. I'm also not done. I'm going to try to grab a different marker. Pink, great. Now I'm worried about these. X squared to 8x squared is just going to be 8. So that's 8x squared, so minus 8x squared minus 16. All right, I don't have an x term, so I don't want to have anything under it, because I like thinking about it as just columns. Now these are going to cancel. I'm going to get minus x, and then 3 minus a negative 16 is going to give me a positive 13. Let me know if there's any steps you want me to go back through or anything that's not making sense. But from here, what we can do... Ooh, do I have a fourth color? Yes, I do. I can write the final answer, which is going to be 2x to the third, 2x cubed, plus 4x squared, plus 8 minus... No, I'm going to do plus... the denominator is x squared minus 2. I'm going to have a negative x plus 13. Or, to make this a little bit cleaner, I might just switch those two around so that it is 13 minus x. Does it make sense how we went from here to here? And are all these steps clear, I guess? If not, let me know. If you have another topic, another question you'd like to cover, please ask away. If anybody's watching on Facebook as well, it doesn't have to just be Twitch. That's who we're answering, by the way. There's lots of comments on Twitch right now, so if it looks like or sounds like we're responding to people you can't see, because we are.
It is exactly that.
All makes sense? Thanks. Yeah, great.
Any other questions? Concerns?
I'm concerned. It needs more cowbell. All right.
Math, English, science, reading,
College stuff.
college stuff. No, it's not exactly the time for college stuff.
Yeah, because it just kind of really just ended, the whole season for that.
I've found that students I tell things about college when they're juniors ask the same questions 6 months later because they're worried that they misremember it. So, yeah, sure, ask if we have no other questions. That's fine.
Mm-hmm. Also, Svea, how's that SAT coming along?
Very quickly.
Yeah? Good things, bad things? Most of the way through it? Not very far into it?
Svea, if you pay me $5, I'll do it for you.
You're so... It's not going to help at all.
No.
Have you figured out if you like one over the other yet? I definitely have a preference. You having fun?
Yes.
Okay. Well, hey, I'll just leave you to it then. If you
Yeah, I was just going to do this for the next 5
7 minutes?
Yeah.
Well, there's definitely enough people watching to where someone else should have questions.
Yes. Now, please ask questions. Science, math, English, reading, essays,
Levi's personal life.
BPL.
Beat you to it. I don't even know if they know BPL anymore.
BPL.
And that's okay.
Since you don't know.
That's okay. It's okay.
It felt very nice, actually. I need to... Ooh.
Finished the ACT, which I thought was hard. I did the SAT English, and I'm actually liking the SAT English better than the ACT. Is it because there's 30-some fewer questions? 31? Still have to do the math.
Nice.
All right.
Math is super fun on the SAT, if you like that. If you
you-
don't, it's
If
not
you're into that
super
kind of
fun.
thing, if you're not
Yeah.
into that, then it's not.
Yeah.
Nope.
I like the
Okay.
ACT English because it's way longer than the SAT English. And the English section is so much fun because there are rules.
You're
and
such
you
a
can
nerd.
identify the question type by looking at the answer choices.
Look,
And then,
we'll get there. We don't want to spoil the test that she's about to take to
True.
see where her diagnostic is.
well.
Which do you prefer? I like the ACT. He likes the SAT. Because
Yes.
he's a loser.
I like the ACT English because it's longer, and then I like the SAT for other stuff.
I like the ACT because it's quick. I like the fast pace. It's my advantage. If I get it wrong, I'm still going to answer it before anyone else.
Hey,
That was how it was in college.
B. Okay. Svea, do you have any other general questions? Let's see. Done English.
The science,
Yeah.
yes, it's going to be hard the first time you take it. And with one little trick, it sounds so cheesy, and I love saying it like that,
Yeah.
but there really is just like one strategy that makes the whole thing so much easier.
Yeah. It doesn't get you a 36, but
No, but it definitely
help.
will jump you a bit.
just let it fall apart.
Never.
It's fine.
Didn't we retape this, or was it just that side?
No, it was more this side.
That's fine. I think that's the side that goes bad anyway.
Yeah. Okay.
It's home, smoke
Let's-
and mirrors.
Very true.
All right.
You did the problem for the factors with the graph. Oh, maybe you didn't do it because I gave you the other problem to do. Did you do something if we have
Probably not.
this 1, 2, 3. Oof.
Nice.
1, 2.
That's
So that's a 2 there. That's a -3 there. We have a parabola.
that's rough looking.
And which of the following is possibly a factor
this out.
of... So let's say this is f of x. Which is a possible... Which is a factor of f of x? So here's your function. Which is a factor of the function? X plus 3, x minus 3, x minus 1, x plus 2. One of these is a factor of that function, and 3 of them are not. Do you know, anybody who's watching, which of these is the factor? I'll give these letters. A, this is a terrible way to do this, B, C, and D.
Yeah.
Ridiculous. I will erase that brace now. Yeah, anybody know which of these factors has to be a factor of f of x given that graph over there?
Yo, I do.
I know you do.
Oh,
Hey,
okay.
hey. Hey, Daniela.
Hey.
Oh,
Hex,
and Hex.
Hex is back.
Look
What's
at that.
up?
People answer questions. Yes, it is. I'm not sure why, but this question type is... Okay, and it seems like you all know why, so I won't explain it. But this question type is, for whatever reason, very challenging, and they ask this type of thing on the SAT because they ask it in a strange way. You understand that if you're given a function that looks like this, that you're supposed to, if they ask you for this thing, what are the x-intercepts? You may not know, but generally people are good at, okay, well, I see a quadratic and I'm going to factor it, and then from there I can set it equal to 0. Some people forget that you're supposed to set it equal to 0, but they just do this because you do it so much in high school. But this type of thing is not as familiar to people, so it trips them up. But it seems like everybody's fine on that, so that's nice. Since I can tell that you're now here, does anybody have any quick questions? It doesn't have, you don't have to give us the question itself, but is there anything that has always been an issue for you? You know, any kind of nagging little thing? Like, do you understand exactly what f of x means? Why it's written that way? Things like that. Any little nagging questions in the last couple minutes? Good job on A, everybody, though. That's good. I think this is one of the most important things to recognize, which is what we taught today, recognizing the connection between factors, roots, intercepts, zeros, and solutions. And setting x or y equal to 0 depending on which intercept you want. I'm gonna need more spritz. You did join late again, Hex. That is true. We forgive you. It's getting so colorful. I don't know if they see. Yeah, I seem to see that. What did we cover today? We covered actually what I just said. So factors, roots, intercepts, zeros, and solutions, and the connection between them. If you want, you can go back and look at it. I think it's an extremely important relationship between things. It's not like a particular skill exactly, but it is a support. I see it as a scaffolding thing. So it's a very important conceptual connection to make between those things. Otherwise, on the harder questions, especially on the SAT, you're going to have trouble.
Also, for anyone still watching, I just posted our Instagram link, our Instagram account. We have one now. Go ahead and check that out. We also have Twitter, Discord, Facebook, YouTube, Twitch, for all of you who are on those 3 different platforms. But check it out. Follow us. See if we're funny in real life.
Yeah, Brady just posts on those things, and he posts funny stuff because he's by far the funniest person that I know. And I know
that's
a lot
cool.
Of people.
That's
I don't
cool.
know a lot of people. He's funnier than us by a lot.
All right. It is time. We're out of time. So thanks for joining in. We will see you guys tomorrow. Don't forget frizz. Factors, roots, intercepts, zeros, and solutions. That's what that means. Just, it looks like freeze or fries. All right. See you guys tomorrow.
Yes. Bye, everybody.